How do gravitational waves make a chirp signal? Imagine listening to a sound that starts low and slow, then suddenly rises in pitch and loudness. That's what a gravitational wave chirp sounds like in space. But how do these waves actually create that distinctive rising signal? Let's break it down. Gravitational waves are ripples in the fabric of space and time, caused by massive objects moving very fast or colliding. When two dense objects like black holes or neutron stars orbit each other, they emit these waves. As they orbit, they lose energy by radiating gravitational waves, which makes them move closer together. As the objects get nearer, their orbital speed increases. Think of it like two cars racing around a track, getting faster as they approach the finish line. This faster orbit means the waves they produce become more frequent and stronger. The wave's frequency, which is how often the waves pass a point, rises. At the same time, the wave's amplitude or size also increases, making the waves more intense. This process continues until the objects finally collide and merge. The collision produces a peak in the gravitational wave signal, which is the highest point of the chirp. After the merger, the newly formed object settles down, and the waves fade away. This entire pattern, starting slow and ending fast, creates the characteristic chirp shape. The key to understanding this pattern is the chirp mass, a number that combines the masses of the two objects. It determines how quickly the frequency increases. Scientists measure this from the detected waveforms to learn about the objects involved. Detecting these tiny ripples requires super-sensitive instruments like the Laser Interferometer Gravitational Wave Observatory, or LIGO. These detectors use laser beams to measure incredibly small changes in space caused by passing waves. When a chirp signal is detected, it confirms that two massive objects are spiraling toward each other and merging. Studying these signals helps us understand how black holes and neutron stars form and evolve. Future space missions like the Laser Interferometer Space Antenna will extend our ability to detect lower frequency waves, opening new doors to explore the universe. So, in short, gravitational waves make a chirp signal because, as two massive objects spiral inward, their waves increase in frequency and strength, creating that rising, sweeping sound we call a chirp. It's a direct record of cosmic events happening billions of miles away, giving us a new way to listen to the universe.